Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. What is the major product of this reaction? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now if you look at the reaction, so it is actually a 4-member ring or cyclobutane derivative, one side attached to Br, another side attached to Cl. And if you look at the reagent, that is sodium in dry ether or anhydrous ether. What is the condition, student? You have studied this already. So it is Wurtz reaction, or some people say Warj reaction. So it's a Wurtz reaction. What is the thing? Previously we have studied, actually these tricks we have studied. If you react 2Rx with in Wurtz reaction, so in terms of 2Na, it will produce the alkane with double number and obviously 2 equivalent sodium X. And in this context the mnemonic or suggestion was, okay, remove this part in this way and attach this R and R, and the another point was that reaction proceeds through radical as intermediate. Okay, an anhydrous solvent is needed. Why? Such that if moisture is present, that can react violently with water and produce sodium hydroxide and hydrogen. So in order to avoid that side reaction, this dry ether condition is used. Now what happens here? Now if I ask you a simple question, between CBr versus CCl, which one is stronger bond? Obviously here it is this CCl is stronger than CBr bond. What is the reason? Because bromine belongs to the fourth row. So here fourth row, carbon is a second row element and chlorine is third row. So the orbital overlap which is responsible for this covalent bond formation is more or better in case of carbon chlorine compared to carbon bromine. So since it's a weaker bond, so under the condition, I mean when this sodium will react, means actually sodium will release one electron, so where the electron will go? This electron will preferentially break the relatively weaker bond. Okay, so one electron from this sodium, that electron will go to the sigma star of this CBr bond and it will break, means it will break like this. So these electron will go, and here actually I should shows half arrow movement of single electron. So these will come with a bond pair and there will be a radical. Actually very simply if I say, you can think in this way, there was a carbon bromine bond. So if it breaks, then bromine will be one radical, carbon will be one radical. I have donated one extra electron here. So what will be the consequence? That extra electron will go to bromine and make bromine minus. Now if you ask me why the extra electron will go to bromine, because bromine is comparatively more electronegative atom. So means it is more electron hungry, and if the electron goes on it, that is comparatively more stable compared to the carbon ion if the electron goes on carbon. So okay, this is produced a radical, and remember these radicals or free radicals are not that much stable. What happens here in this case? They react further, they're very reactive. Why? Because this radical carbon, if you look at it, is a 7 electron species in complete octet. That's why it's very reactive. Some people say this radical is more stable, this is less. See, we can compare the stability, but remember radicals are metastable species, they are not very much stable. Slightly more, slightly less may be there, but not very stable there. Now what happened? In the next phase, another molecule of sodium releases another electron. Okay, so in this case sodium plus electron, and what it produces, these electron reacts with this chlorine similar fashion. So here what it results, both side 2 radical, and obviously here Cl minus and plus Br minus. Now these radical combines together. Since movement of single electron, I am giving half arrow, or it is called as fish hook arrow. So what is the product here? So it is actually a bicyclic compound, both side 3-member ring. Now you may ask one question, that sir, why this reaction happen? Remember, this is actually a intramolecular reaction, And remember, intramolecular reaction are always faster than intermolecular reaction because they have proper conformational orientation, means this carbon and this carbon in close proximity such that their orbital can do effective easily overlap and form this sigma bond. Now you can ask me one question that, sir, this 3-member ring has ring strain. Yes, I agree it has, because under these reaction condition it will be the product. It is not that much stable, but remember, radical is far more unstable, so that's why it can react and produce this. So this is the overall discussion. Now what is our answer? Our answer is option B. Now if this question appear in your exam less than 30 seconds, how can you solve? Student, for that purpose I always suggest look at the carbon count. It's a C4 substrate, carbon 4, C4 ring. So and if you look at option D, it's a C5. It is illogical. I have given sodium ether, nothing extra. Now if you say Wurtz reaction or Warj reaction, it's a double, then it should be C8. Why C5? Not possible. Gone. Now after that there are 3 options. Logically, if you think it is cyclobutadiene, remember this is anti-aromatic according to Huckel rule, means very unstable. I have already discussed many lectures on this aromaticity and cyclobutadiene. Please visit, I shall provide the link. So it's a very unstable, and remember, if the molecule is unstable, it is very difficult to prepare them. And if you prepare also, they'll not stable in this form, they'll react further. It's a dimerization. Now it's not stable. So now question is option B versus option C. This is also not, student, very stable because 4-member ring. This is sp2 carbon atom. The bond angle should be nearly 120 degree ideally, sp2 hybridization, but what is the bond angle? Nearly 90 degree. So it has a significant ring strain. Under this situation or in this situation, you may think like that, okay, this could be the product because it's a moderately stable 3-member ring. I agree, ring strain there, but they are overlap in such a way, I guess banana bond, in this way they can increase the bond angle, so they use more p character to make this bond destabilized. So in this way these will be the major product. But the actually main message for you, C5 eliminate this, cyclobutadiene anti-aromatic eliminate this. So what is remaining? 2 options. This is called process of elimination, means 50-50. So it is very helpful solving MCQ and it can reduce the burden. Now using your common sense you can get this option B, but apply common sense when you have enough preparation. Okay, so this is the overall discussion. I believe this video will be useful. Thanks for watching, and if you really consider the content of my channel is worthy, then please help this channel to grow. And regarding any doubt about the logo of my channel, please read this part, your doubt will be clear. So see you in my next video. Bye bye.